So hi everyone, thank you very much for joining us today and buckle up for another session, deep dive session. And this time we are going to talk about AppSec, a new exciting technology that it's powered by AI technology. And I'm hosting today one of my best friends here in Checkpoint, Daniel Goldstein Bar. And you're in quarantine, right?
my children now.
Yeah. So hi Daniel, and some of you remember Daniel from his previous role. He joined us in previous webinar, and your previous role was the IaaS group manager, and you changed your role like a year ago, right, Daniel?
Almost a year ago, yeah. I've started to manage the CloudGuard application security that is part of the Infinity Next area and platform at Checkpoint. Yes.
And for by the way, for how long are we working on this project, this technology?
This project, the CloudGuard AppSec specifically, is started by the fact that Checkpoint acquired a startup company almost 2 years ago called ForceNock. This product was acquired by Checkpoint, was integrated into Checkpoint's code system and the system and integrated into the systems of Checkpoint. And we, after integrating it, we have started to deploy this solution at our early availability customers for almost a plan that was running for almost a year. And 5 months ago, we have released this product as a general availability for all our customers. So in general, we are running with this product for more than 2 years after acquiring the ForceNock startup.
I see. Okay, so the agenda for today, so Daniel, you are going to cover what is AppSec, and without all the marketing bullshit, we are going directly to the business. Then I'm going to show you deployment, and I'm going to show you a few common use case. One is on deployment of autoscale on AWS, and another one on Kubernetes as an ingress controller. And then, Daniel, you are going to talk about the configuration and monitor, and at the end, we will have time for Q&A. Sound good?
Yes.
So, Daniel, please share your screen. I will stop sharing, and let's start.
Yes. Okay. Yes, we have already a question in our chat. Yes, the deployments that Shai will discuss about are auto scaling group, which is eventually a new solution in the public cloud. We have provided a solution for auto scaling in AWS and auto scaling in Azure, which are relatively new solutions, and also our solution for Kubernetes. So I will discuss about, and it will be a brief introduction about AppSec. I hope that everyone can see my screen, yes, and discuss about what is CloudGuard AppSec, how it is related to Infinity Next, because the names are combined together sometimes, and then we will move to the deployment. So CloudGuard application security, or CloudGuard AppSec, is part of the Infinity Next architecture. The Infinity Next architecture is a platform developed at Checkpoint that is composed of two main components. One is the agent, and the agent can be installed in the IaaS of the customer, infrastructure as a service. It can be installed in his Kubernetes environment, in containers environment, in the public cloud or in the private cloud. It can be installed almost on every asset that the customer has. And the second part is our FOG. FOG is the internal name of the Infinity Next, but basically it's a cloud service, a complete SaaS service that provides configuration, management, and all our engines and all our security engines are running as part of the FOG that are integrated, that are working together with the agent to provide all what I've mentioned before. So this is the Infinity Next architecture. On top of the Infinity Next architecture, we have products. The first product that was introduced as part of the Infinity Next architecture is CloudGuard AppSec. And CloudGuard AppSec, as I mentioned before, is a WAF-based solution. It's what we call here WAP, Web Application and API Protection, with additional of IPS, and we combine it together as application security for your web servers, and it provides security for web servers protection and API protection. And if I'm going into the slide, the CloudGuard AppSec is installed as to protect the servers. It means that it protects, that it inspects all customers, all users and customer requests forwarded to the server. It inspects the traffic and decide if the request is malicious or not. If the request is malicious, it prevents it, and if not, it forwards it to the server. It prevents all the things that we have here: side defacing, information leakage, digital theft, user session hijacking, and more. And it is powered by contextual AI and intrusion prevention. These two engines and more are running as part of the cloud service that I have mentioned before. And in addition, all the configuration, you will see it in the actual deployment presentation that Shai will present. All the configuration is fully managed by a complete SaaS service. We have a web API and web UI that you can manage and configure the system via a web SaaS service. The contextual AI and intrusion prevention systems are engines that are running in the cloud and provide a unique manner of CloudGuard AppSec to protect your web server. We have an ability to identify and to learn the requests that are coming into your web server. And by learning the site and learning the users and learning the behavior of the user, we are able to identify deviations of malicious requests, because we assume, and it's always the site works as is, that most of the requests that are coming to the sites are not malicious. Like more than 90% or 95 and more, 99% are legitimate traffic. So we start the application by a learning phase. We learn the system. Usually it takes us between 2 to 4 days. It depends on the amount of requests that we see at this stage. We learn the traffic and we learn the site and we learn the user and the behavior of the user. And when we actually move the application into a prevent mode, we are able to identify malicious requests and legitimate requests. And in the case and in the usage that we have with contextual AI and intrusion prevention, we are able to increase our rate to identify true positive requests and to lower our false positive rate as well, which is very important as identifying the true positive. In addition to our web application firewall, we are able also to protect API. APIs are usually can be directed to the server from 2 points. If a developer has a API request into the server exposes API. And the second main issue is applications, phone application or application running on every device that customer has are using APIs to my server to extract information. So we are able to secure APIs, and we are able also to enforce schema validation. We support Open API Scheme version 3.0 version. And if your server and your APIs that you expose are written in via Open API Scheme, we are able to enforce the fields and the values and the types that the API exposes, that your server exposes to your customers. We have also additional feature as part of CloudGuard AppSec, which is preventing malicious bots. This is running in a unique manner by injecting a dedicated JavaScript into the customer's browser. And this JavaScript that is running in the customer environment is collecting user behavior. And once the customer issues a post method into the server after completing, for example, a login page, we are collecting all the site and we have some specific score, and based on this score, we're able to identify if the post request coming from the customer is malicious or legitimate. So this is an additional feature that we have as part of our existing solution of CloudGuard AppSec. So to summarize, and before I'm giving the stage to Shai, and we actually can see the deployment itself. So we are talking about a very precise prevention by, again, as I mentioned, we are working very hard to increase the true positive rate, to lower the false positive rate, and to do it everything with a very low maintenance. We do not, our system usually can work with a very low, even less than 5 exceptions. We also provide the ability to create manual exception, but our main focus of the product is very low maintenance. So usually after a learning phase and moving to prevent, the customer should not put a large amount of maintenance into the system in order to tune the system, because we have the ability to learn the traffic. So this is the auto adapt to application changes and automated cloud native deployment, where we have solutions in the marketplace and integrating with auto scaling that you will see in the next session. And so I will be here also for Q&A after Shai's deployment and solution. So Shai, I'm giving you the stage.
Yeah, thank you, Daniel. I will share again my screen. And, guys, please, if you have any questions, put it in the Q&A, and Gal and also Daniel, I think, is on it, and they will answer our questions. And of course, we will have time also at the end of the session. So let's start with talking about deployment. What are the deployment options? We have a few deployment options. So the first one, and this is the easiest, I think, one is the virtual appliance. So you get an appliance, and you can find these appliances on the marketplace. It's on all of the top 3. So it's on AWS, we have a single gateway you can find there, and you can also find a scale set. Also for Azure, a single gateway and scale set. In GCP, for now, we have only a single gateway, but we are planning to add also a MIG, a scale set, a MIG solution in the near future. So this is the most easiest one, and we are going to deploy together a scale set on AWS. We have another solution where you can install it on Kubernetes as an ingress controller with an nginx ingress controller. If you want to use another ingress controller, you can also do that. And we also support container images that we will provide you the images for that. So this is another option. And the last one is nginx agent. If you have an existing deployment of nginx that are doing a reverse proxy for your application, you can put on the host machine also our nano agent. But I suggest in this case just to create a new deployment with a scale set or a single gateway instead of starting deploying the nano agents, because it's a operation system. It's based on the distribution. It's not working on all of the distribution. Correct me if I'm wrong, Gal. So this is, I think, will be the best approach. So let's see actual deployment. So this is a common use case. We have 2 scale set on AWS, but it's the same also for Azure and GCP. We have one scale set that is running those 2 applications, App A and App B. It has just one certificate, a SUN certificate with two domains. And we have another scale set, test checkpoint online, okay? 2 scale set. And on top of them, we have an internet-facing application load balancer that expose those applications to the internet. So this guy is listening on port 443. And in some cases, customers has also a CloudFront with AWS WAF. But I promise you that we are doing a much better job. This is a static rule-based WAF, and we are doing a much more sophisticated inspection. So just to show you that, so I'm pointing, so app A check for online is pointing on this one. I just want to show you that. So if I will go CMD and I will ping app A check for online, you will see that it's pointing on the external, okay, on this ALB. And this ALB also is holding on the certificate manager. I upload the two certificate basically. So he's doing, he's opening he's opening the traffic and looking on the host header. On based on the host header, he knows where to route to traffic to which scale set or target group. Let's see it here for a moment. So this is the external load balancer on AWS. Okay, you can see this is the external FQDN name. And on the listener, I have just one listener that is listening on HTTPS. And he has a two certificate and he has a few rules. You see for each one of the FQDN, he has a rule. Okay, it's easy one. So what I want to do now, I want to create a parallel path. Okay, a parallel path. I don't want to touch. So I want that everyone, all the traffic will keep working while I'm creating a parallel path. So I will be able to deploy our inspection mechanism, do a QA, run traffic, and only then when we are sure that everything is working as expected, we will change the CNAME to our FQDN. Okay, so let's start doing it. So I'm going to create, so I'm keeping this internet-facing load balancer, and I'm going to create an internal load balancer. I will create an ALB, as I want just one listener, but you can use also a network load balancer, or even a classic one, whatever you decide to use. So let's create an internal load balancer, and we're going to create two target groups, okay? Because I cannot use the same target groups of that this guy is using. So I'm going to create an internal load balancer with two new target groups. So I'm going to do that right now. So let's create a target group, two of them. It's the destination is instance, and this is AppSec, and we are using HTTPS, and it's on the VPC web app. Okay, and the health check is also HTTPS. And we are not going to register any instances to this target group because we have the autoscale. The autoscale, we're going to configure it later on. The autoscale is going to configure the target group. So it's going to add and remove instances based on what is going on the autoscale. So I'm going to create this target group, and I'm going to create another target group for the test. So instance, test, AppSec. And again, it's listening. My clients are listening on my server. Our scale set is listening on port HTTPS on the same VPC. Also, health check is HTTPS. And I'm not going to register any target groups, any instances. So you will see here that if I look on this one on AppAB, this is the existing one. With I have just in the scale set, I have just one instance, so we see it. On this one, on the new one, it doesn't see any targets. So what I'm going to do now, I'm going to the autoscale group, and I'm going to tell him to update also the new target group. So I'm going to, on the autoscale, I'm going to AppAB, I'm going to edit it, and on the load balancer on the target groups, I'm going to add the new target group that they've just created. So this is the AppAB AppSec HTTPS. And we're going to do the same for the test. and then we're going to check in the target group that it was populated with new instances. So in the test, I'm going to edit it also, and I'm going to add the new target group, test AppSec. And now if I will go to the target group that I've created, we will see that is populated, okay, with a new instance. We see a new instance target group, currently is unused, okay, because we need to attach it to a load balancer. We didn't create a load balancer. Once we will create a load balancer, it will start using this target group. So let's create the load balancer. And we're creating an application load balancer, internal ALB, and we are not using internet facing. It's going to be internal, and it's going to listen on HTTPS. And the VPC is the web app VPC, and I'm connected to, I have two subnets, so he is going to drop a two INI on those subnets. I will upload just one certificate for now, and then after we'll create the load balancer, I will add to the listener the second one. So let's say this is going to be the default one, AppAB. And those certificate is getting them from the certificate manager. We will see it later on. And for the security group, I will allow all. Later on, I can restrict it. But for now, let's use the allow all VPC that I've access a group. And the target group is existing one. And we will choose the available one are app A. This instance is going to be registered, so because it's got it from the autoscale, and we are creating it. Okay, so we have a listener now, and we have just one certificate. We're going to add an additional certificate, the one for the test. So this is the one that we are going to add, the test. And now I'm going to create the rules. Okay, so we have a default rule that send everything to AppSec, and we're going to create additional rule. So the first rule is going to be host header, and I have a three application, right? So first rule for app A, and is going to forward the traffic to app A. Okay, it's app AB basically. We'll save it, and now I'm going to create an additional rule. And this one is going to be for app B. And we are going to send it to the same target group, app A target group. And the last one is for the application test. So we're going to create an additional rule for application test, host header, forward to test. So basically this is it. We are done with this stage. We created the internal load balancer to target group, and we register the scale set to the target group. Okay, so now they should be, let's say, just check it, that the target groups are populated. We see AppSec A, and it's unused. This one is healthy, and this one, AppSec, unused. Why it's unused? Let's check the load balancer, And this one is good. AppSec should be good. Unused. Wait, it's unused. Unused. Oh, now it's okay. Just take time. Okay, now it's okay. Okay, so we are good with this configuration. Now we need to deploy basically the AppSec. So we have a CloudFormation template that basically deploy the AppSec scale set, and the CloudFormation template, it not just deploy the AppSec scale set, it also deploy an external load balancer. And the type of load balancer that we deploy a network load balancer. But feel free, if you don't want to use the network load balancer, you want to use an existing one, or you want to use an application load balancer, feel free after the deployment to destroy this load balancer and configure a new one that will point on the AppSec scale set. But before we will start deploy the autoscale, we will run the CloudFormation template, we need to do some configuration. And the first thing that we will need to do is to make sure that the scale set, those instances, can retrieve the private key of those certificates. We don't want to host them directly. We don't want your certificate on our portal, on our SaaS service. We want you to keep the secrets on AWS, or to keep them on Azure, on a Vault. Okay, so the thing is, I want to show you, so you have an option on AWS. If you will go to the certificate manager, this is where I upload the certificates, and the load balancer can use them. So I upload. Once you upload certificate, you will need to provide the certificate body, certificate private key, and certificate change. But AWS does not allow us to pull the certificate private key from the certificate manager. Okay, just local resources like the load balancer can do that, but the third party cannot do that. So what we are doing, we're using a secret manager, and on the secret manager, I'm going to upload the private key of my certificates. And so I'm going to store the two certificates. I need to choose here other type of certificate, and the type is a private key. You need to put here private key, and you don't put the certificate, the PEM, what you have in the PEM here in the field. You need it in base 64 format. So how do you do that? I copy it to my Linux machine. So let's do that. So here, so here you can see I have my private key for my app AB certificate. So if I will take a look on it, priv key, you see this is my private key certificate. Okay, but I need it in base 64. So how do you do that? Open SSL base 64 dash A, capital A dash in private key, and out prive64 key. Okay, so now the certificate base 64 will look like this. Okay, so this is the first one. So what we need to do is to copy it from here. And don't try to copy this certificate to Windows machine open there, because it's going to, it doesn't going to work. So copy it from here. So I'm going to copy it, and I'm going to copy it right here, and click next. Now, for the tag, I need to point on the ARN of the certificate in the certificate manager. So the key name is going to be certificate. Certificate. Awesome. And on the certificate manager, let's open here certificate manager. And I'm now handling this one, the app AB. So I need to take the ARN, and I'm going to put it here. And I need to give it a name, so app AB. Wonderful. So I have the first one. Let's do it also for the test certificate. So store a new certificate and a private key. And let's generate the base 64 for the private key. And I already have it here. So cat prive 64, prive E64. Let's take it. I will take it from here to here. Wonderful. And certificate. Certificate, and I need to take from the certificate manager the ARN of test, which is this one. Voila. Awesome. And this is going to be test secret. And let's store it. Okay, so we are good with this one. Now, basically, how does those guys in the scale set, they need to communicate and register in the Checkpoint Infinity portal? For that, we need to generate a token on the Infinity portal. So what we are going to do, we are going to create an asset. Okay, assets basically are the application that we are going to protect. So let's go to the Infinity portal. And guys, if you don't have an account on the Infinity portal, just go to portal.checkpoint.com. You can register, and you can create your own tenant. And now we don't enforcing a license, so you can just start right after my session. You can protect your application. We are not enforcing license, so you can deploy as many agent as you want, and you can protect your application and give us feedback. And we have a few customers, I think more than 10, and quite huge customers that use it, and we get wonderful feedbacks. So I will log into the Infinity portal. I need an OTP. Let's wait for the OTP. Okay, so in the Infinity portal, I'm going to cloud. Okay. By the way, we have many applications, the Harmony, CloudGuard, and this is the application security. Okay, we are talking about AppSec, application security. And I will start with asset. I will delete everything. We have run a session the morning, so I have some garbage here. Sorry about that. Okay, we're ready to go. So I'm going to asset. I'm going to create a new asset. Okay, asset, basically it's application that I'm going to protect. So I'm going to protect my web applications. By the way, I didn't show you my web application. They are now protected. They are not protected, or they are protected by AWS WAF. So HTTPS app B, a checkpoint.online, and also I have app A here, and I have my test app. Okay, so those are the applications that I'm going to protect. Awesome. So let's create a new asset, a web application. So let's call it app A B. Okay, and the application URL is this one, app A B HTTPS. So all the application are behind the same load balancer. So if I don't want to create a different like a protection structure for those applications, I can put all of them in the same asset. But for now, let's just put app A. I will edit later on. I will add the rest of the apps and click next. And this is the practice that I'm going to use, web attack mitigation and IPS. And for now, I will leave it in learn detect. By the way, this product is on development all the time. We are going to add more practices. We are also going to add access control in the near future. And we have many plans for the future. Maybe Gal will be able to elaborate about our plan, what is the roadmap later on. So I will click next. And he asked me how to distinguish between the users. So the options are source IP or XFF. As I told you that, let's take a look on the diagram again. I'm going to place the AppSec behind a network load balancer. Okay, network load balancer preserves the source IP, so I don't need to use XFF. So, but if you use ALB that is hiding the source IP behind the load balancer IP addresses, you need to use XFF, and not just that, you need to make sure that you configure the application load balancer to put the XFF, okay, inside the packet. In our case, we distinguish based on the source IP. We don't need to look on the XFF. And here I need to choose the deployment type, so the deployment. So we are creating a new profile, okay, and we are going to install it on a VM on AWS. Okay, we have the option also on Azure, and you will see here also a GCP in the near future. You can also install it on-prem on a VMware. And this is the gateway will reach the protected web application at this address. So what is this address? This address is the internal ALB. So he has a FQDN. We are going to grab it from AWS. So I will go to EC2. And I will navigate to the load balancer, and I will take the FQDN from there. So this is the internal load balancer. Internal load balancer, I will copy the DNS name. Okay, and why do I use this the DNS name? He has also an ENI, an IP address. I can take it, but I can put only one. And he has, if you remember, when I deploy the load balancer, I choose two subnet. So I will get. So AWS is going to translate it to one of the IP addresses. So this is why I use FQDN here. So HTTPS, and this is the address. I will click next, publish and enforce policy. And now it's going to create an asset, and it's also going to create a profile. So what is a profile? Profile basically is going to be created for each deployment. So for example, if I will create another scale set on Azure, I'm going to create an additional profile, okay, for Azure, because it will have its own separate token token ID, and this is how we manage it. So let's take a look on it. So this is, we see now we are on the profile tab, and I have here a token, and this is the maximum number of agents. We are talking about concurrent agents. Okay, so if you, we are going to deploy in a few moments the CloudFormation template, and there you need to choose what is going to be the maximum number of instances in the scale set, and this needs to be matched the value over here. So, and we can also put it AppSec gateway, AppSec gateway, AWS California, North California. And we need to take the token from here. And let's publish the, before we publish the change, you remember that on the asset, I put the FQDN of this guy, the internal ALB. And we're using NGINX as a reverse proxy. And the thing is that NGINX has a limitation for the maximum size of the host name, and it's 64 bits, if I remember correctly. And we need to, on our configuration, we can push configuration to the NGINX. So in the next release, we are going to fix it. You will not need to add this key, but for now, we will need to add this key. So let's add this key, and don't worry, by tomorrow, I'm going to send you not just the recording of this session, I'm going to send you all the, I have a text file that I'm using for this session, and I'm going to share with you also this text file with all the commands that I'm using, and you will see later on all kind of YAML files, so I am going to share with you those YAML files as well. So agent RPM RP manager, this is the value that we need to put here in the key. And we need to set the value, the server name hash bucket size to 128. So this is the value. And now we are good. So let's publish the changes. By the way, Gal, if I don't have a agent yet, do I need to click the enforce policy?
Well, it won't do much. It's important to the point that you have an agent, so you can enforce at the end.
Okay, so basically we are ready. So now just to show you again, we have the asset and we have the profile. Where is the profile that I've created? I think it's this one. Yeah, North California, it's this one. Let's just make sure that the asset is associated with this profile. Yeah, the profile is AppSec AWS North California. Perfect. So I need the token from here, and we're ready to deploy the skill set. So again, what we are going to deploy now, we are going to create a CloudFormation template that is going to deploy the skill set and also the internet-facing network load balancer. So how do I get this template? Just write in Google, search for AWS checkpoint templates. We have many templates for all kinds of products and use cases, and we are focusing today on the CloudGuard AppSec auto-scaling group. You see, we have also a CloudGuard AppSec. This is a single instance, and this is auto-scaling. And the auto-scaling, we have one template that is deployed into existing VPC, and another one that is deploy also a new VPC. We are going to deploy it into existing VPC. So we choose this one, and we are going to launch the stack. And the stack name, this is the stack name. I don't need to change it. You can if you want. The VPC is the web app. And I will choose the two external subnet, web sub public 1 and public 2. This is going to be the instance name, ASG1, 2, based on the number of the instances. Allow from anywhere. The key is CP. This is the key that I'm using, CP California. And the agent token. The agent token, I want to remind you that I'm taking it from here. This is the agent token. I will copy it and paste it here. Enable EC2 Instance Connect. Yeah, why not? I can connect it over the AWS Web Console. Password hash, I don't need to use my SSH keys to access the instance. Forg address. Forg address, basically by default, it uses checkpoint, but for the future, there might be customers that will have their own Forg. Gal, you want to explain what is Forg?
Yeah, so the Forg is our cloud component to which the agents are connecting. So in the future, we will have this component also as on-prem to allow privacy and performance for local agents.
Okay. We need to choose the instance type for this session. I will go with the smallest one, C5 large, the minimal number of gateways and the maximum. And the maximum here need to match. So if you change it later on, it needs to match the number here, the number of agents in the profile. And now we are going to the certificate settings. So I can provide the certificate from here. And also, if I'm adding more application and more certificate, I will show you how to add it later on. So for now, we have the option to add 2 certificates. We will add the one for app A and B, okay? And I will show you how to add it, to add them later on. So the certificate, we are using HTTPS, and we need the certificate ARN. So certificate manager, and we need for this certificate, we need the ARN. Certificate ARN. And we need the secret, the private key. So we take it from the secret manager. We need this app AB, and we need also the ARN. And as I told you, we are not going to add the test certificate. I will add it later on because I want to show you where to add it. Okay, so I'm adding the certificate ARN and the secret. Yeah, go ahead, Gal. Yeah.
There's a question about if you can show the diagram again. It's a question where we are deploying this.
Yeah, so just let me start the deployment.
Okay.
Create a stack, and yeah, what are you asking?
So in the deployment we are doing, we have internal load balancer and external.
Yeah.
And the question is where we are going to set. So this is the AppSec scale set. So whoever asked that, there's no name. This is where we put, this is where we're deploying.
Yeah, this is the AppSec scale set. This is what we are deploying right now. Basically, I just deployed the minimum that I set is 2. It's going to deploy 2 because there is no traffic. So I created 3 here, but
thank you.
Okay, so the scale set is going to be created. It's take like, I think, 3 minutes, something like that. And we will see also the agent that is being added over here. And we are going to see also a pop-up here. Like, so let's see. Let's refresh it and we'll see the status.
As part of the creation process, in order to create a secure manner of access between the VM to the secrets manager and the ACM, we are creating an IAM role that is specifically allow the VMs that are part of the autoscaling group to connect to the AWS ACM and secrets manager in order to retrieve the private key and the public key. No one else other than the autoscaling group VMs can access these repositories and can access these services and these secrets. So in the IAM role, we have specifically the ARN of the secrets manager, and we provide list and describe operations of this specific ARN. And this is also as part of the CloudFormation template that is being deployed. It is a part of the creation. Of course, that after the VM is successfully created in AWS.
So let's see it. So Daniel, we have the 2 instances, the AppSec instances that have been created, and we will see, this is what I want to show. So we see that the instance is associated with the IAM role. Okay, so we'll go to the IAM role. I want to remind you that we want to add also the access to the certificate and the private key of the test website. We just did it for the app A and B website. So I'm going to the IAM role, and the scale set is using, it doesn't, they are pointing, the 2 instances are pointing on the same role. As you can see, I have 2 policies. So in order to add the certificate, this is for the certificate and this is for the secret. So for the certificate, I'm going to edit this policy. This is the certificate. So I'm going to edit this policy, and the certificate, I'm going to take the test ARN. I'm going to edit. This is the test ARN. Okay, so this is the test ARN, so I can save it, review, and save it. We'll open it again. And now I need to take the secret and the secret of the test, the ARN. This is the ARN. Right. So this is the secret. I will edit the policy, and I will add the the secret area of test. And so basically we are good with the deployment. We finished the deployment. Let's see the CloudFormation template, and it's completely, and it's done. So, so the external load balancer is being created. This is the new one. And he has a DNS name. So what I will want to do now, while creating it, so I have another machine over here. It's on the internet. And what I'm going to do, I'm going to edit, as I don't want to change on, I'm managing my DNS on GoDaddy, my dummy domains over there. I want to keep the current path, okay? This is the production, okay? And now I want to check the parallel path. So let's ping to the external load balancer that has been created, and this is the IP address. Okay, so what I'm going to do now, I will add it to my host file. And this is for app A. Let's do the same also for the rest of the apps. So this is B, and this is test. We'll save it. And this is 122. So let's ping it. 122. So this one is good. So we are ready to test it from here. Let's clear the history here. So it's not ready yet. Oh, now it's fine. Okay, so now it's we are good. Let's move on to the next deployment. The next deployment that I want to show you is ingress controller on top of Kubernetes. So basically, what we are doing here, you see, we have a few applications. I just going to deploy one application on the Kubernetes. I have a Kubernetes cluster on AWS, but you can use any Kubernetes that you want wherever you deploy it. And I'm going to run just one application and one service that listening to requests for this application. I'm going to show you the YAML, and we are going to write it together. And we are going to deploy via Helm chart. We have a Helm chart, AppSec Helm chart, that is going to deploy this structure. So basically, Helm charts, it's provide the ability to deploy a collection of Kubernetes services and containers in a single command. So what we deploy two pod. We deploy pod with two containers. One is the nginx ingress controller, and if you are using other ingress, it's fine as well. And we also deploy the nano agent, checkpoint nano agent container. And on top of that, we are running a service. We deploy a service and also deploy a load balancer. In this case, it's a classic load balancer, and we are going to support in the near future to deploy Helm charts with other load balancer. You will be able to put it as a parameter. So you will be able to, based on the deployment, if it's Azure, GCP, or AWS, you will be also you're going to be able to choose what load balancer type you want to deploy. So, and then after we deploy this one, we're going to deploy ingress. And the ingress basically is the configuration that is going to be sent to the ingress container nginx. And this is what is going to enforce. And I'm going to show you, and it's a really quick and easy deployment. So let's switch to the Kubernetes here. I will show you first kubectl get pods. So I don't have any pods right now. And I don't have any SVC, any services, and I don't have any ingress right now. And so the first thing that I'm going to deploy is the application that I want to expose to the internet. Okay, so I have created the YAML file. This is my YAML file. This is my YAML file, and in this YAML file, I have a container. It's called simulate juice shop application, where you can buy juice online. And this is the spec. So I have just one replica, and what is important here that the container port is 3000. Okay, TCP. And in the same YAML file, I also deploy a service. Okay, and the service is going to use port TCP 8080, and the target port is 3000, is the one of the juice shop. Okay, so let's deploy it. Kubectl apply -f juice. Okay, so the service and the pod has been created. Let's check them just to make sure that they are up and running. So I have just, this is the juice shop container. And in the pod, we have just one container. And we have also the service, the SVC, and it's listening on port 8080 on the cluster internal IP. Okay, this is IP, an internal cluster IP that is not exposed anywhere. So we've created this application, and we've created the service. Now let's start deploy what you see over here. So first I need to give the Kubernetes the secret. I'm going to publish the application juice.cpappsec.online. This is also a domain that I hold on GoDaddy. And I've also already created a certificate for this application. And again, it's need-based 64 private key and certificate. So if you will take a look, I've already generated them, like I've shown in the previous demonstration. So I have those two files, cert64 and the private 64. Okay, and I've created the YAML file from type secret. So this is I show I upload to the Kubernetes. I deploy the secrets. So the command is let's show you secret cat secret file, and Okay, so this is the kind, it's a secret. Okay, and I put the TLS key and the TLS certificate. Okay, and this is a base 64. So I just generate those, change the certificate and also the private key to base 64, and I put the value over here. Okay, and now I'm going to deploy it, kubectl f secret, and I need apply. Okay, and the secret has been created. Okay, so we have here the juice secret, and now we are ready to deploy the Helm chart. So if I will search for a repo, you see that after I deploy Helm, I don't have any repo. So I need to add the checkpoint repo, and for that, I will set the command help repo add the cp AppSec and the URL. So this is the command. Okay, and now if I will search the repo, you will see that I have the checkpoint repo, the AppSec repo with the Helm chart. And now I am ready to deploy it. I'm not ready yet. Now I need also a new token, and it's a new deployment, so I need a new profile. So I'm going back to the Infinity portal on the assets. I'm going to create a new web application, and it's going to be called the Juice. And the application URL is https juice cp appsec.site. Click next, and this is the practice that I'm using. This is the default one, and the source IP, I don't have a load balancer. I have a load balancer. It's a classic, so I see the source IP. And the deployment is Kubernetes. It's a new one, Kubernetes. Okay, click next and click done. So you're going to create a new asset and also a new profile. Okay, I will take the token and I'm going to put it. I have a command that we need to use, and I'm going to show you it in a moment. So this is the command to install the Helm chart. Helm install cp appsec, and this is the repo, and set token, and this is the token that I'm using that I get from the Infinity portal, and the set platform EKS. On the admin guide, you will see you have other parameters. You can set different. There is default values for the SSL port and also for port 80, and he has a default value. So I'm going to deploy it with the default values. Okay, and it was deployed. And basically, what is deployed right now? He deploy an external load balancer, a classic one, and he deploy also the service and the pods. Okay, and the last command that YAML that I will need to run is the ingress. Okay, the one with the configuration. For the nginx ingress controller. But before we run the ingress, let's take a look and see that he created the pod with the 2 containers and also the service and the load balancer. So to do that, let's start by kubectl get pods. And we see here the AppSec, this is the pod, and we see that he has two containers. So if I will run the command get kubectl describe pod, and this is the pod that I want to describe, you will see that he has two containers. And you see that which one I was describing? Okay, now I see it. So we see the nginx ingress. Okay, this is the CP AppSec ingress, and we see another container, the nano agent container. Okay, so the ingress is listening on those ports 443 and 80. And now, if I will run a kubectl get SVC, you see the load balancer that is being deployed, okay, with the external IP. This is where I need to point juice, okay, juice at CP AppSec, and you see that he's pointing port 80 on those two ports, one for SSL and one for HTTPS, okay? And while you deploy the Helm chart, if you want, you can also change those high ports. Okay, so now we set the Helm chart. Let's move on and configure the ingress configuration. We need to push the ingress. So if I will run a kubectl get, cat ingress, I have a configuration with the ingress. And in the ingress, you see this is the kind, this is ingress. He has a name, and he's going to listen to this request. This is what you need to see in the host header. Juice CP AppSec, and the rule for juice CP AppSec is going to use the secret name, juice secret. This is the YAML file that we upload the secret to the Kubernetes, and is going, and the backend is the juice shop. This is the pod with the juice shop, and the service port is 8080. Okay, so let's apply also the ingress, and basically this is it. Everything should work. Kubectl apply ingress. Okay, the ingress now is configured, and kubectl get ingress, we should see the ingress. Okay, so basically now we are good. So if I will take here the external IP, so basically what I need to do now, I need to go to the to GoDaddy and put a CNAME that point on this external IP, but I will do it. Let's put here on the host file, but let's ping the IP of the external load balancer of the Kubernetes. So this is the one. And let's juice cp appsec dot site. This one is fine. Yeah, and it's working. Okay, this is the juice shop, and he has the right certificate, and this one works. And I want to generate like an attack. So what I'm going to do now, I'm going to, it's not a real attack, but I'm going to generate something. Let's see if we can detect it. So if I will go to the monitor important events from the last, from today, I'm going to see 2 events. This one is from now. Yeah, this is the time here in Israel. And I see the detect. Okay.
Because you're on the default, which is detect.
Yeah, exactly. Remote
you can see there the
execution.
match sample. You can see the match sample. So if you go all the way down,
yeah,
you can see the match sample, the system inject ls PWD user that you put in.
What do you say? Say again?
You can see the actual string that you've put. So one above that system,
yeah.
this is what you copied to the user.
Yeah, exactly. Yeah, this is what he put. Okay, nice. So, Gal, basically, I finish, and you can take it now from here. You want to give a review of the Infinity portal. What are the settings that can be made on the asset level?
Basically, you showed everything. One thing that I would like to show, which is cool, we are not able to ask control here. I can do that.
Yeah, you can. Yeah, you can take control.
So I'll request control. So we kind of show what you have. So for the asset, you can configure the protected URL, the URLs that you are facing the users, the protected URL on the other side of the reverse proxy. You can play with what's the source identity. So on the wizard, you add source IP and XFF, but you can actually do it according to cookie and header key. And then if you put that, for example, you can choose, sorry, if you put cookie or header key, you can get the name of the field. So you can choose according to which field you can do. This is the cookie header key, which I had before. It would take a second to refresh. Sorry. So you can choose the key in the header to distinguish user between. So I'll get back to source IP. And you can add trusted sources that you already know that are trusted. You don't want them to be enforced. You can add exceptions. So exceptions can be added from the practice itself. So if I'll go all the way down, I can add exceptions here, but I can add them also here. So exception will mean action, skip, accept or drop, or just don't log according to a condition, which can be the URI, source identifier, parameter name, whatever you want. You can have like whatever you want to have. And I actually want to show a cool thing that we usually don't get to show in these sessions. If you enable this switch here, the tech preview, you will get some features that are in EA. So make sure that you know what you enable. So by switching here, you're not enabling anything. By switching here and configuring stuff that appear when you switch them, you are enabling stuff that's in EA, which is okay, but take into account that it's EA. But in means of AppSec, what you get in the asset screen, you get this new tab, which is Learn. And this is kind of a gamification way of that we do to show you the advance of the learning of the system. So you get nice statistics about kind of events that you have seen, how much time since the traffic began on this asset, recommendations. So currently system recommend to keep learning. Along the way, it will recommend to move to prevent for critical and above, and then for I and above. And we show you, if you put the cursor over the learning level icon, we show you the stages, the levels of the learning. So we go from kindergarten to basic school to high school, graduate, PhD, and professor. And you see how much, what are the requirements to move between the stages, between the levels, up to graduate, which is the fourth level. You don't need to do anything, but let the system see traffic. And it will say you need 999 more requests and 6 more hours to proceed. And at some point, I think that at graduate, recommendation will change to, you can now move to prevent from critical and above. And from graduate to PhD, system will actually ask you to do something like add to trusted sources. So the system will learn more, and then it will be able to do prevent from I and above. Now you can move to prevent whenever you want, critical and above, I and above, whatever. But this is what the system suggests according to its learning. And another thing, with time and by seeing more traffic, we will show tuning suggestions. So events that the system saw and identified as critical or medium, but it is not sure about them. And you'll be able to choose if they are benign or malicious, which will again help the system to learn more. So for each suggestion that you have here, you will have some information, and then link to log screen filter for these kind of events. So events from source IP, events from a key related to key in the cookie, things like that. So you will be able to go over the logs and then decide if these are benign or malicious. Go back here and press the correct button, and it will allow the system, it will help the system learn more. So as we say here, AI process AppSec can reach better accuracy when trained by a human. So you help us train the system. You can always go to the tuning decisions that you did. So once you pick something here, it will go to here, and you can undo the change. So nothing is final. And this way you can see how the system learn, follow up on it, and even help the system to learn. So this is the cool thing that I think that you can use. Remember, you need to enable the tech preview. It's per admin. So if you have several admins in the tenant, each admin will have to enable it for itself. Okay, and I think that's it. There is one.
Gal, also a new feature is the access control that I see over there.
Yeah, so access control is in EA. It's still early EA. So if you want to start, contact your local Checkpoint representative, or contact us if you're from Checkpoint, and we can help you. It's basically a layer 4 firewall that we provide in some cool way to configure with all this all new concept that we are bringing. And you can run this access control on the same agent that you run the AppSec. It might not mean a lot if it sits behind a load balancer, because it's a layer 4 firewall. We will have the ability to do access control in layer 7.
Based on XFF?
Based on several parameters. It will be along the way in this year, I think. Don't want to promise anything. But you can start using the layer 4 firewall, but coordinate it with us. And I think there's another question in the question and answer. So what kind of access is needed between the gateway and the Infinity portal? So we do HTTPS, so 443 to the from the agent that sits on the AppSec gateway to the Infinity Next cloud, to the fog basically. It's not to the portal. And permissions are for the whole portal. So for the whole tenant, they are not per asset. But you can have read only. So you can go to the global settings of the tenant. And then under users, you can add users as the roles are, role can be admin, read-only, user admin, but as you can have multiple applications for the tenant, like Harmony stuff and Infinity stuff, you can do it per application. So you can give an admin only for specific application, or read only for everything, but admin for Infinity next, for the AppSec. Okay, so I think that's it.
Gal, so we need to investigate and to see what is going on with the deployment on AWS, if we have some kind of new issue over there, and we will get back to you on the post, I hope by tomorrow, and also so you will see the recording, and I think that we'll take the recording from the morning, that
everything worked there.
Yeah, so
we did something too fast today, and something didn't work. I think that's it.
Okay. Anyway, if you deploy, if you have any questions, please post it on Checkmates on the AppSec, and Gal is over there, myself, also Daniel, also other developers will answer each questions that you might have. And also I want to show you a nice feature that we have over here is feedback. And I didn't know that, but Gal, you told me today that this feedback, when someone put a feedback over there, few R&D guys are getting this feedback immediately.
Yeah, so this is showing as an alert to us managers in the Infinity Next, and we will answer it whether it's good or bad. So it's not supposed to be the support channel, but if you have a question, if you have something that you think that it's not working as it should, or a suggestion, or if you want to say that things are working fine and you are happy with it, you can do it here, and someone will get back to you for sure.
By the way, if you guys want to start using it and you have questions with deployment, anything you might need help with that, just post us in Checkmates, and we will get back to you as soon as possible. And we promised that we'll assist you with any deployment or issues that you might have. So, Gal, thank you very much.
Thank you, Shai.
And see you on our next Tech Talk. I didn't decide what it's going to be yet, but it's going to be soon. Okay. Thank you. Bye-bye.
Bye-bye.